Hello, everyone, and thanks for joining us here on our live lab walkthrough for our Retrieval Augmented Generation lab. My name is Andy Moser, so I'm an architect here at Worldwide Technology in our Advanced Technology Center. I've been at Worldwide for a little over 8 years now in multiple roles. Most recently, I'm on the AI Labs and Learning team, where we're responsible for creating content, all kinds of content, labs, videos, articles, around all of our AI solutions in our Advanced Technology Center. Prior to that, I was a sales-focused role in our central region, kind of dedicated to VMware. And my background is mainly compute, virtualization, networking, and storage, so kind of a traditional infrastructure guy. So, and then prior to that, I was at a company here in St. Louis called Enterprise Holdings. You may have heard of Enterprise Rent-A-Car, National Rental-Car. Worked there for 15 years, doing their private cloud and terminal server farms. So today, before we get started, the first 30 minutes of this is probably just going to be a lot of me talking. So if you have questions, please put them in the chat. And then once we get through that 30 minutes or so, and we've walked through the whole lab, we'll do a Q&A where we can answer some of the questions and do some live feedback if needed. So wanted to start off with kind of a history of this lab. So I would say back in probably December of 2023, we started looking at how can we do some labs around AI that are repeatable, on demand, and easy to use for our customers. So if you're familiar with our AI Proving Ground or not familiar, I'll talk a little bit about it. So that's our kind of section of our Advanced Technology Center where we have all things AI. So, I think our investment's $500 million and counting into what we've put into the AI Proving Ground with, NVIDIA, NetApp, HP, Dell, all our partners in there having a piece of their solution in there that we can showcase to our customers for, labs, POCs, long-term labs, things like that. So starting with that, we wanted to come up with some labs that we can put on our platform that, again, are usable on demand by multiple people at the same time. So we started looking around, we started with, how could we emulate something like ChatGPT in a lab environment? And that got me looking at some various things. So like a lot of people these days, I work from home most of the time. So I had some hardware at home. My personal PC had an NVIDIA video card in it. So I started looking at things. How could I possibly build a demo on the hardware I have that I could then use that as a base to replicate into probably a more advanced solution in our Advanced Technology Center? So I started looking at things like that. And NVIDIA actually has an offering today. It's called Chat with RTX. So if you have an RTX class or higher video card, you can download this software, and it's basically it loads an LLM for you, and it creates a basic RAG, Retrieval Augmented Generation solution for you on your box. It's free. I highly recommend you try it out if you're wanting to get interested in some of this stuff. It's an easy way to learn, and that's where I started in my journey to get this lab going. So once we got that going, I had that working, talked to my peers and other people on my team like, hey, is this something we would want to do in the ATC? And if so, how do you guys think we could do it? So it kind of came up where we have all of this hardware in the ATC for labs and learning, for POCs and things like that. The challenge that we had, which is actually a good challenge in my opinion, was that was constantly being used. So we constantly had customers in and out of there using different bits and pieces of it. So we needed some dedicated section of that where we could do labs around. And that wasn't possible right out of the gate because of the demand with what we had going on. So we looked at, okay, maybe we'll buy some PCs and put them in the data center and make a lab around that. Looked at that for a little bit. That was an option. And then kind of came into, well, let's look at cloud. We can do this in AWS. We can do this in GCP or Azure or any cloud. So I started with AWS, basically trying to duplicate what I had done on my gaming PC, basically, of setting up Chat with RTX on an AWS instance in our ATC section of AWS. So we got that working. It worked pretty good, but it was still kind of basic, I thought, in terms of how we could do it. So we wanted to do something more advanced. So started doing some more research and kind of came into a few things. One of which was Ollama, which allows you to run, it's an open source tool that allows you to run an LLM locally on your machine. Sorry. Okay, yeah, sorry. It allows you to run an open source tool called Ollama on your machine that lets you run LLMs locally, and then you can do, you can chat actually with Ollama, but more importantly, you can use the API to pull from other solutions. That's kind of what this lab turned into. So having Ollama running there, looked at what I call the RAG-in-a-box solution. I found several different offerings of this online where people were trying to do the same thing we were trying to do. So I was able to kind of piggyback off some of that with getting an Ollama instance set up and getting, it was called a Jupyter Notebook, if you're familiar with those, as the front end where I could kind of ask questions of the LLM and then inject my data that I wanted to use for RAG into that solution. It was a very good solution, but at the end of the day, it was pretty, I would say, a little bit more advanced than what we were trying to go for. So I started looking for something, again, a little simpler for this basic lab for the first go around. And that kind of led me towards a product called Anything LLM. So Anything LLM, another tool you should check out, is a GUI front end that basically lets you use, you can choose from multiple different LLMs, multiple different providers. You can use different APIs for things like OpenAI, Anthropic, things like that, where you can load your own API credentials if you have a paid account into those, and then you can use it to do, basic chats, basic RAG, and kind of what I'm going to get into with this lab here in a second and show you how that works. So after we got that going, again in AWS, our next challenge was how do we publish that on our platform? So that took a little bit of side work, some internal stuff with how we publish things on our platform. We had to get the lab to work in Terraform. So got it working in Terraform, got it working in AWS, had a working lab. We were ready to publish it. And then we kind of came to an agreement where with some new solutions in the AI Proving Ground, we were able to leverage some of our GPUs that we have for this lab without impacting customer POCs, without impacting any of our other engagements that are going on with the hardware. So we used a solution called Run AI, which allows you to fractionalize GPUs. So that runs on Kubernetes. So we were able to carve off a section of a GPU. So this lab that we're going to walk through is actually using, I think, 10 to 12 gigabytes of a L40S NVIDIA GPU. So we've got that section of that GPU dedicated for us for this lab. So rather than having to carve off an entire system, we were able to carve off a piece of it, and we can move that around. So if for some reason the actual GPU that we're using for this lab needs to be used for another POC, we can just spin up the container on another environment that we have available, and it seamlessly is going to move over to that new GPU using that as its backing. So once we had that made it a lot more appealing for us to deploy. So we switched and kind of pivoted back to everything worked in AWS. So it was probably a 4-month process of learning from starting at my PC in my basement to what you're going to see here today of the lab on our platform running entirely on ATC hardware, GPU in the ATC, and everything there. So once we got that working, we've kind of published it, and it's been a pretty popular lab, I would say. We've had a lot of launches of it. I think 500 launches since we've put it out there in, I think, June that it came out. So it's been a pretty popular lab. We've gotten a lot of great feedback on it, lots of questions, lots of things to, people have asked, can we do this, can we do that? So we're, working on adding some changes to make the lab a little bit different in the future, and more advanced labs based on top of that. So I'll go ahead and get started with the lab right here. So this is the page where you would see if you go to our platform, wwt.com, you can see under labs and learning. These are the labs that I have checked out. Here's some recommendations for things that you might want to check out. Since I've already checked this lab out, it's going to show up for me as a lab that's already there. So I've already got it launched, and it's disconnected me, so I'll hopefully reconnect quickly. Okay, so now that we're in the lab, Here's a quick overview of the architecture. It's pretty basic. So this is everything that you're seeing from the front end. The GUI is running on a Windows 11 jump box in our ATC. Then we've got a Llama serving up Llama 3 8B is the model that we're using, and that's on an NVIDIA L40S fractionalized provided by Run AI in our AI Proving Ground. Anything LLM is kind of the thing that makes a lot of this possible. So that's also running the database for our vector database, LanceDB. And then we've kind of pre-cached several worldwide websites and some fake documents that we made up to kind of use to demo RAG throughout this. So I'm not going to go through everything here and read this, but like at a high level, some of the concepts we're going to cover. So GPT, generative pre-trained transformers. So you guys have all heard of ChatGPT. That's the stuff that's behind the scenes. So LLMs, large language model. We're using Llama 3 here. So this is the model that we'll be using for showcasing RAG questions with RAG and without RAG. The vector database, this is pretty important to the solution. So this is what's going to store all of your RAG data. So think of it, you have an LLM, it's going to be trained on a set of data at a particular point in time. So you have that particular point in time, and it's not going to know about, your medical records or your company's PTO policy or things like that. That's not going to be in there. So if you wanted to use the power of an LLM with that external data, that's basically what RAG is. That's kind of how I explain it to everybody. So it's the power of an LLM with data that's important or maybe private to you, company data, proprietary data, things like that, where you can leverage the power of the LLM with that data and do queries and models based off of that. So tokens, it's the basic unit of text that's processed by an LLM. So think of those as, it could be individual words, it's spaces, it's punctuation marks, special characters. So those are obtained by splitting that sort of text into different words. So like a sentence of 7 words might be with a period or something like that, might be 8 tokens or something like that. I'm making up the numbers, but it all adds up to be a token that gets input into the LLM. So with context, in natural language processing, it refers to the surrounding words or tokens considered when processing a particular thing in the text. So the size of the context window is important. That means basically how much information can you provide to the LLM. So if the context window is, say, 1,000 tokens or 1,000 words or something like that, you're not going to be able to put in, an entire novel into there and ask a question about it. So the size of the context window matters in terms of what you're trying to do there. And then I would say the biggest thing with this too is the text splitting and chunking. So that basically involves breaking down, large text into smaller chunks. So think of text splitting and chunking as important. It helps with the context. So if you have a sentence like, I went to Paris for spring break, something like that. If you don't do the splitting and chunking right, it's not going to have the whole context of what you're talking about. So it might break down, I went to Paris, but it forgets the for spring break part. So you may ask it a question, where did you go for spring break? And it's not going to know based off of that. So figuring out all those parameters is really important to this. And with this lab, it's very basic. There are hundreds of different variables of things you can change to tweak it for your environment, to make it more in tune with what it is you're exactly trying to do. So this is, again, just to kind of showcase the basic power of it. If you're actually going to do this in real life in production or something like that, it would be a much deeper investigation into all the settings and how you want to do it for your solution, for your particular use case. So that kind of covers how RAG works. I'll walk a little bit through some of this other stuff with some of the importance of how you prepare your data. So basically, like I said earlier, with an LLM, it's trained on a data set from a particular point in time. It's not going to know anything about anything beyond what it's trained. So you could retrain that LLM. Say, hey, I've got a month's worth of new data. I'm going to retrain it. Doing that is an expensive proposition. It requires a lot of compute horsepower, a lot of GPU horsepower to do that, and it's an expensive proposition. So that's kind of where RAG comes in here. It's a an easier way to augment an existing LLM with that data. So with the external data, the first step is to basically split it up. That's the splitting and chunking. It's going to break that stuff up into smaller forms, and then it's going to embed that in your vector database. Once that's done, and then it's going to look through there, it's going to take your query. So say you ask a question of, how much vacation time do I have? The system's going to go through and get the chunks of text that are related to like your company's PTO policy. And it's going to craft a prompt with that knowledge of what your company's PTO policy is to the LLM. And so it's going to know the PTO policy, and it's going to know your question. It's going to combine those, and it's going to use the power of the LLM to say, hey, how much vacation do I have? And it's going to come back with something along the lines of, hey, you used 8 days, you get 15 days this quarter or this year, something like that. And it's going to pull that all together. And if you would, this actually shows you a little bit of what you would see if you did it without RAG. It would basically say, hey, I don't know the information. I don't have access to your personal employment information or leave records, but I can tell you, here's some things I would ask. Go ask your HR representative about how that works, things like that. It's going to be helpful, but not as helpful as you possibly could have it if you used RAG. So kind of now that we've kind of walked through that at a high level, let's walk through actually doing it in real time. So let me pull the lab over here. So one of the first things we're going to do is verify if we have RAG set up and if it's set up properly on each of these things. So in anything LLM, there's multiple workspaces. So you can think of a workspace as kind of your personal area for how you want it set up. So I could set these up with different models, different prompt queries, different data in the RAG database and things like that. So I'm going to show you this one here, which is the no RAG database. And this one doesn't have any RAG. So here are the documents that we have available for RAG. And if we look at our workspace here, we can see that there's none in there. So when I ask a question that might be specific, which we will do in a little bit, to stuff that is in here, in the no RAG workspace, it's going to come back with a generic response. And then if we look at the RAG workspace, we can see that, hey, these 4 documents are already embedded in that RAG database. So if we ask the same question that pertains to stuff in these web links here, it's going to have the ability to generate a more accurate response. So let's go ahead, and we've done that. We've verified it's enabled. And we can get started with our first query. So we're going to ask the no RAG workspace a question around worldwide technologies ATC. And of course, copy and paste is not working. So I'm going to ask that question. And it should provide a wrong but generic response. It seems to alternate between the Worldwide Telescope Astronomy Control Telescopes and worldwide, there's another one, Air Traffic Control, both of which don't exist. The telescope one does sort of exist. It's just a slightly different acronym. So it took a little bit when we were doing this lab to kind of come up with something that I could repeatedly guarantee was fake. It's actually harder to make something fake 100% of the time, believe it or not. So that was challenging. So we're going to ask that same question against the RAG database, the RAG workspace. And since this one is embedded, it's embedded with 4 links, which are web pages on the WWT.com website about like our leadership, our philosophy, and things like that, and the AI Proving Ground. So it should come back with a response. And I caveat this should with everything is kind of going to usually works, but sometimes based off of the randomness of an LLM, you're going to get different answers. So you guys might all ask this question in this lab at the exact same time, and you might get slightly different answers. But we can see here, let me expand this a little bit. So I asked the same question, and you can see I got a lot more information in the response. So it's basically telling me about what is the Worldwide Technology Advanced Technology Center. It's giving you that information, some details about it, and what it's used for. And one of the cool things here, it's going to show you, if you pick the citations, it's telling you what the source of that answer was. So it's saying, hey, I pulled bits and pieces of this answer from these sources. These happen to be 3 of the sources that I've embedded in the vector database for this lab. So if I pick one of these, I can see, hey, it pulled it from here, and that's the information it pulled, and the probability of how accurate that is. So 66% accuracy is kind of what you're seeing here on that. And those will change, each one will be slightly different, 53%, and it tells you exactly what information it's pulling in.
Hey Andy, sorry to interrupt, but we had a question in the chat about the no-rag workspace.
Yeah.
So the question is, it came up with that answer, that incorrect answer about air traffic control. Would that be considered a hallucination for
Yes.
AI?
Yeah, that's 100% accurate. So yes, that would be considered a hallucination, which we do talk about a little bit in the lab guide. But that's a good call out. So those things are hallucinations, and it kind of leads to just I would say kind of a basics of anything with LLMs. Verify the accuracy of the response. We use this stuff daily, and we're constantly developing and iterating on it, and it's not perfect. It's very similar to you do a web search. You're going to get an answer that's probably pretty close, but it could also be completely wrong. So, do your own research on those answers. We use it for a lot of our work, but it's more of I would say a time saver than a replacement for actually knowing what you're talking about, is a good way to look at it. So, as you can see, so those are kind of the results of if we do, a RAG query. So then let's ask another question in the no RAG thing that's very specific to Worldwide. And I'm asking it who is our vice president of human resources. And it should come back with somebody who does not exist. I do not know who Sherry Daniels is. I don't know if she works at Worldwide, but I know she is not the EVP of human resources here today. So that's obviously, it's finding something out there. It's trying to give you the answer that it thinks you're looking for. In this case, that's a total hallucination and is not correct. So if I go into the RAG workspace, which again has a little bit more of our company information in it, and it's going to spit out the correct answer. So it's giving the correct answer, Bob Farrell, who is our VP of HR. And it's going to show you again where it pulled that from the leadership. If you look at our leadership page on WWT.com, it's going to list, Dave Stewart, our founder, Jim Cavanaugh, going down the list of all of our senior leadership. And that's where it pulled that info from. And again, that was a 56% match. So now that we've got this, let's say you find some new data. You've got some new data that you want to add into there. How would you do that? So if I go to the RAG workspace, I can look at, hey, here's the documents that I have. So here's those 4 web links I've talked about a few times where it's pulling a lot of the information. Here's a document that is not in that embedded in the database that we're going to use. And this document is, I actually asked ChatGPT to make something up completely fake. Again, this was a challenge to get it to be completely fake 100% of the time. This is what it came up with, and we'll show what this is in a second. So I'm going to move that in there, and I'm going to click Save and Embed, and it's going to embed this into the vector database. So now that document is available for everything in this workspace if you query against it. So then I'm going to ask this question, what is that? So what is PEX? And it's going to say, this is what it stands for. So PEX stands for Photosynthetic Energy Conversion System. So if we actually go look at that document, that's what that document's about. So this is a completely fake document that's there. But if I go ask the same question in the no RAG workspace, It's not going to know what it is, hopefully. Yes. Okay. So it says it stands for Preferred Exchange for Community Support. I don't think that's a real thing. I don't have time to look at it here right now, but I'm going to go 90% that this is fake and a hallucination again. So you can kind of see the contrast there of, here's just asking an LLM your basic, very pointed question, but a basic question pointed towards something that you're very much interested in. And then if you have, a bigger data set that's got your, your personal data or your customer data, or whatever data is important to you, that's a better way of kind of looking at it. And it's going to give you that more accurate response. So if I minimize this here and just open this up, it's going to open up in Word. So yeah, I mean, this is if you ever ask ChatGPT to tell you a story or write a story about something, this is probably a pretty familiar output of kind of the format that it kind of comes up with. They're all very similar, but it's created a whole, International Institute for Sustainable Energy, made up fake people that invented it and what it does. It actually sounds pretty cool, whatever it is. Free energy from plants. I'd be on board with that. But in this case, it's completely fake.
Andy, another question from the chat. Will AI always try to assume what you are asking is correct, meaning you're not trying to fake it out? And is that why the hallucinations are there?
So let me see the best way to answer it. So a lot of times it will straight up tell you that what you're asking is not real. And that was a challenge I had with this lab and with some further labs I'm working on. The LLMs have gotten smarter, if you will, with the way they do their data. And I've tried asking similar questions here. Like I've used a new model and asked the same question, what is PEX? Just asking it. And it's basically says that's not a real thing. So they are getting better, I would say daily. I mean, new models are coming out all the time with, being able to limit incorrect responses, if you will. Does that answer the question?
I believe it does. I think that shows the challenge. Kevin said, yes, it does. Thank you.
Okay.
It shows the challenge we had in creating this lab is that we want to prove how RAG works. And, we had to kind of fake out the LLM to make it give bad answers to show that RAG is, something that you can get and add that information into the LLM. So. Yeah.
Yeah. I mean, and that, kind of like I said at the beginning, that was one of the, you would think a lot of the challenges around here were technical. They were in a way. That's what we kind of deal with every day here with the technical side of it. But this was something new of, how do you ask a question? That's not really, I didn't learn that in any certification, but it was challenging. And then you're kind of going through, looking at how do I ask a fake question with a fake answer to an AI solution? So that did take some time to kind of figure out. And as we've gotten into different labs and things like that, it's definitely become more challenging from a lab perspective. It's challenging because I need you as the lab user to have the same experience, whether one person uses it or 20. I need to be able to somewhat predict that the outcome you're going to get is within reason the same. That was a challenge. So getting that done, at least today, this lab works the way it should. So, but with any of the AI solutions, they're constantly advancing. There's some of the newer models, it's really hard to trip them up with fake stuff. So we'll just keep this lab around as is for a long time, so we can kind of show it the way it is without all the enhancements. So here's a couple quick more here before we kind of wrap it up, but we can say, who invented this? It's going to say, there's no single inventor creating PEX, a collaborative effort. It's going to show the citations. Again, it's just pulling it all from that doc. One thing to note here is it's not pulling it from, it's pulling it just from that one document. You're not seeing any of the WWT links because those aren't pertinent to the question that was asked or the answer that it's trying to provide. your mileage may vary with this. I have seen it where it says it sourced something on the World Wide website, and I'm like, I cannot figure out what that is because this is not real. So the hallucination aspect of that is definitely something to always keep in mind with anything you're doing with AI. So that's kind of it for the lab. This was a fun lab to build. In the end, it did take a lot of time, a lot longer than some of our labs take, but getting it through from, literally starting on my PC in my basement to moving it to, AWS, to moving it to our platform, and kind of that whole genesis was definitely an awesome learning experience for me. And I think a lot of the people that helped build the lab too. It was a team effort. We leveraged other people on our team to kind of help with different aspects of it, like with learning Terraform. I didn't know Terraform when we first started this, when we were going to publish this. So I used ChatGPT to ask me to help write Terraform scripts. It's great. It's great for that stuff. Saved me lots of time in getting the development work done. So then once we got that, we got it published, and it's been kind of great since then. So, and that's led to, some other labs. We've got another lab and learning path just around generative AI, which kind of uses the same front end as you're seeing here. And that's focused mainly more specifically on just the LLM aspect of it, not any extra data or things like that. So would be like a traditional ChatGPT. So you want to ask it a question, you've got an LLM, you can have a workspace in here. There's no RAG or anything like that, but it's showing you how, kind of the importance of prompt engineering and things like that. How you phrase your questions to get the response you want is important. So I would say that's kind of it for the lab. So kind of open it up to if there's any questions.
Would you be able to go a little detail on how the architecture is, the lab architecture is set up? I do see you have OpenShift and there is Ollama as well as Llama. I'm trying to understand how exactly they are working in this.
Yeah, sure. So the Ollama aspect of that and Run AI. So what you're seeing right now is just a Windows jump box. So anything LLM is running on a Windows jump box. So that's handling all of the front end. So Ollama is running as a container on an OpenShift cluster. And then it's accessing a GPU, also running on a Run AI container that's running on a cluster with GPUs. So Kubernetes is pretty big in how this particular lab is deployed today. When we started, it was all running locally on one machine because that machine had a GPU. That was kind of our limiting factor in how we first started developing it. Was we had to have that one-to-one relationship of machine to GPU. Then with Ollama, we figured out we could have, one machine with a GPU, and that's running Ollama, and then we could serve it up to many. So we went from that to then with Run AI, it's 100% on Kubernetes, where kind of like I said, we've got a container for Ollama, and that's on, I'm trying to remember the name of the cluster. I don't have it off the top of my head. That's running on one cluster, and then we have another cluster that is running Run AI that has access to GPUs. So that cluster, I think, has like 16 NVIDIA L40s. We're just using 25% basically of one of those L40s to provide that. Does that answer your question?
Yes, thank you. And the front end, you mentioned about Jupyter Notebook. So this anything LLM is essentially a Jupyter Notebook?
It's kind of like that. If you're familiar with Jupyter Notebooks, I was not when I got started in this. Jupyter Notebook was a foreign concept to me. I thought Jupyter was spelled differently, but it's spelled with a Y with Jupyter Notebook. So that's how little I knew about it getting into it. So in a sense, yes, this is very similar. With a Jupyter Notebook, though, the way you're kind of doing it, it's like you're actually running the code in Python, usually, where it's saying, hey, instead of me typing in, who invented PEX, that would be embedded in your Jupyter Notebook, and it's going to use that as a variable to kind of then run another line of code that's going to hit your inference server that's going to do that stuff. So Jupyter Notebooks, it's something we use heavily here now. And for people who are doing this on a daily basis, like data scientist types, the AI, ML, ops type people, Jupyter Notebooks is a pretty common tool that they would use as their interface to, a GPU. At the end of the day, there's a GPU or multiple GPUs behind the scenes making all this possible. And a Jupyter Notebook is a front end that allows you to do that.
Okay, thanks.
Sure.
Hi, thanks for your presentation. I was wondering, have you found that, say you enter a prompt and it's not giving you exactly what you're looking for, through iteration and through honing of your prompt, that you're able to then get it to what it, a more satisfying response? Is this kind of a continuous, continuous improvement using this?
Yeah, I would say, so you're talking about just like asking an LM in general, or like with RAG enabled or specifically?
With RAG enabled.
Yeah, so I would say it's twofold. Yes, it's kind of an iteration of your prompt. Like you could ask, what day comes after Sunday, and then you ask it, and it may not, like I don't have a calendar or something like that. So I would say it's twofold in how you ask the question and what data is embedded in your database. So if you ask enough questions, and I haven't gotten there yet, with stuff that it's just obviously not in the data set, or maybe it's not in the data set in the format that it needs to be, eventually you are going to run into a wall where you're not going to get an answer. That will happen. But usually with what I've found is the kind of, the more I craft the question, the better the response is. And that actually leads me to something I just remembered from when we first started doing this. I was trying to use historic stock prices as the source of data for RAG. So I was trying to say, hey, I found some GitHub repositories with historic stock prices for like Apple, IBM, Microsoft, things like that for like the last 30 years. And I was embedding that information into the database. And I would ask it a question like, what was the closing price of Apple on June 5th, 2007? And it would come back with a number. The math was completely right, but the source of the data was completely wrong. So I would say, hey, no, you just gave me the price of IBM on that day, not Apple. I need Apple. And I never got to there. I never got to the end where the answer was correct. The math was always right. It was just adding the wrong numbers, if that makes sense. So that kind of led me to kind of pivot to what I was doing, and do something more just kind of straight text, straight word, like with HTML files or Word files, things like that, where you can get a little more control over it for this particular lab for the demo. But like that's a perfect use case of it, where it's a good example of how that, how you embed that data, how you split and chunk that data. So it was basically not having the full context of, what was going on in June with Apple. So I could have figured out, hey, I could change my, the text splitting that I was doing. Instead of like 1,000 tokens or, chunks, I could split it up into 100 or 500 or 1,500. Quite honestly, I didn't have time to continue playing with it because we kind of pivoted with what we were going to do. But it was a challenge that came up in the development of the lab that in that particular case, we didn't get past it. So we kind of pivoted to, a different model.
Thank you.
You're welcome. Well, any more questions out there, Bill?
Yeah, I don't see any in the chat, and thanks for everyone for participating there. Andy, would you mind kind of bringing it up and closing out, kind of showing the labs and learning that are available to everyone on the call on WWT.com?
For sure. So if you go to WWT.com and you click on, I'm just going to go back to the home page here, And I'm going to go to labs and learning. So yeah, if you go over here on the left from WT.com with labs and learning, you kind of can see, and these are recommended for me based off of feedback I've provided on our platform of things I'm interested in. So yours will probably be different based off of your use of the platform or things you've chosen to be notified on. So I can go through here, and these are ones that are recommended for me. And then I can go through, like here's some ones. Let's look at AI and data. Here are some of the labs, specifically labs and learning paths around AI and data that we've got published today. So you can see like here our AI driver's license. This is a popular one. Kind of goes through some of the basics of what I was saying with hallucinations, how you do prompts, how do you be responsible with AI, things like that. So that's a great one that gets a lot of feedback with people. Today's running through that one. It kind of gets you the rules of the road with AI. And then some other ones get into, a lot greater detail around, networking, storage, high performance compute. We've got some good ones we're working on now with some of the new NVIDIA blueprints. This one's around, generative virtual screening for drug discovery. That's a lab out there. And then, so this is kind of all the stuff focused on, this is in my area, it's kind of the AI focused stuff. But if you go back to, the library, you can kind of search, SD-WAN or something like that. And it's going to bring up, that's because I'm searching in this library, of course. Look at all the labs you may have around SD-WAN. So you can kind of filter through, there's, I don't know how many labs we have around that have SD-WAN capabilities in them, but there's quite a few. So I highly recommend going to our platform and, searching for what you're looking for and check out some of these labs. The on-demand ones, you can kind of filter here if you want to just see things that are on demand. And just to reiterate, on demand means you can launch it live. Once you have an account, you're immediately able to access it and start doing stuff with it. And that's a lab that would be dedicated to you. So you're not in a world where you're sharing it with somebody else. You're going to you do something, it breaks something for somebody else. So they're completely sandboxed and things like that, which is very helpful for learning. And I recommend for this lab, go in there and mess with it, break stuff, change stuff around. Feel free to use it for what it's for. And it's a playground for our customers and partners to learn. So I would say leverage that fully. And if you find anything interesting or break anything, or you're curious, leave comments on the lab, and we definitely read the feedback and we'll respond. Or you can reach out to me too directly, because my contact info is on the event. So awesome. Well, thank you everyone for taking the time out of your day to kind of walk through this with us. Appreciate your time, and look forward to hearing from you in the future.